Welcome back to Hasbro's Hive. As a result of the Govee videos I've done on a temperature and moisture monitoring device that's just really quite useful, I was contacted by a company called Steel Camel, and they have a product that they sell called Moisture Hog. And it's a desiccant, but it's a different kind of desiccant. And it's supposed to be quite powerful, much more powerful than a normal silica gel desiccant. So they were kind enough to send me some samples. We're going to do a series of tests. This is the first one. And I want this to be a controlled environment, but roughly simulate the conditions we would have in our gun safes or our powder cabinets or storing primers and things like that that are moisture sensitive. And so that's what we're going to do. So we're going to weigh out in these small cups here 30 milliliters of water. That's about 30.5 grams of water. And we'll set that down on the bottom. With it, we'll also set one of the moisture desiccant bags. So a Moisture Hog in one and a silica gel desiccant as well. And all these are straight. They haven't been opened. They're all sealed up, etc. So they are still just performing as they'll be at their best, in other words. Then what I'm also going to do is scatter some brass on the bottom of it. And we'll see, because the brass will also tarnish a little faster a lot faster in the presence of high moisture. And so we'll see what happens. And then we'll also put in our sensors in each one. So we'll track specifically the temperature and humidity changes in a sealed box. Now, temperature is going to go up and down. And the reason it's going up and down, they suggested that to kind of turn the air over and exercise the air and make the moisture levels change as much as possible. And of course, the colder the air is, the less moisture it'll hold. But the hotter the air is, the more moisture it'll hold. And this cycling of that will pull moisture in and out of the system and help to, accelerate maybe any changes we might see. So what I've done is, if you can see this well, this is the sensor, one of the sensors that was in this room where we're going to put this. And this room changes more often than others. It's still controlled, but it'll change up and down maybe 15 to 20 degrees, sometimes more. And then humidity, you'll see, will track that as well. Now, humidity is actually fairly high here in the Midwest right now. It's a cool spring day, and so we see a lot of moisture, storms coming through. So we're going to see a lot of cycling of temperature and humidity up in this particular place. Whereas the other safe, the other sensor I have is in another safe, and it's much more stable, and it just really never has an issue. So we're going to try it up here and exercise these cans. So they'll all be sealed. There's seals on top of these cans to keep moisture out. But we're going to trap what is in there, what's in that water cup, and see if we can get it to transport through the air to the desiccant, but keep the humidity level still quite low. So that's what we're going to do. Let me get it set up, and we'll load the cans. All right, if you can see, here is the Steel Camel in the desiccant bag form. They have it loose and they have it in the bag. So we're going to take this bag and put it into our can. I've already put water in there and several pieces of brass. So we'll do that, and then we're going to drop in our Govee sensor, a labeled cab, and that's going to go in here as well. So then we'll take the can, and you can see these are all brand new cans with good clear seals. And then we're going to close it up and store it over towards a window where we know there'll be large temperature and humidity cycles. So I'll set up the same thing, but this time with a silica gel. And then we're going to come back and we'll keep monitoring, because these sensors you can read right through the can. So I should not have to open these. And we'll check them after a few days, and we'll keep track of them and see how they go and see when they stabilize. It could take a while, so we'll check at least after the first 5 days, but maybe every week, and we'll see how long it takes. So it should be a fun experiment. The application, of course, will be a better desiccant to control ammo storage or to put in the safe with your guns. So let's see what happens. All right, we're almost 2 months later now on our desiccant experiment here between a silicone gel typical desiccant and our Steel Camel polymer-based desiccant. And so let's open up our cans. Now, if you remember just from the previous part of this video, we put in a Govee temperature humidity sensor in each one of these. They were closed at the same time, exactly same amount of water placed in a cup. It was like 30.5 grams, something like that, of water in there. I'll post all these pictures and data here for you on the side screens. Into each thing, we threw a few pieces of brass in there and one package of each of the desiccant. Now, as far as desiccant amounts go, The silica gel had 6.238 specific grams. That's what the package weighs at the beginning. So technically more silica gel by mass. And the Steel Camel had 4.702 grams at the beginning. It's just the size of the packages that were pre-done, ready to go. So I really don't know which can is which. Now these were set over by a window where it has exposure to some sunlight on and off, temperature changes, and humidity changes. And you'll see that in the data. It's been changing a lot over the last 2 months here in southern Indiana, which is where we are. So the humidity and springtime and temperature changes and storm fronts, everything is have been affecting these. Now inside these sealed ammo cans, you could still see the effect of the weather and the temperature and things like that. If you weren't in a perfectly sealed environment like this, that could be, those changes could be even more dramatic, but you'll see in that data, it's pretty dramatic what we saw going on in here. Now humidity-wise, the reason we did it this way is this is by far the worst case for humidity, because we have a fixed volume, a lot of potential water, or lot of potential vapor and water that can disperse from these cups into this small volume. And so it's by far the worst case. So let's open these up and take a look inside, and then we'll look at some of the numbers that we get from our data. Well, that's not the best way to treat your powder measure in the background. All right, and then we'll open up this one as well, so we can keep from losing it. Why that lid popped off of that one. Okay, so not sure how well you can see down in here, but our water has not spilled, and there's a definite difference in the water level. I put brass inside of here just to see, you know, how it might migrate and corrode, and I don't know how well, if you can see that well or not. There is just a slight little bit of corrosion in here because this humidity has been so high, and we'll talk about how high the humidity is on the brass. But that's, you know, that's sort of normal. It was worst case on the brass, and that's what I wanted to see. This is by far, again, worse than any condition I would put in, you know, in a safe or in storing ammunition, anything. This is trying to make these systems absorb as much as possible. And so here's our Steel Camel, or excuse me, our Govee sensor for our Steel Camel. We'll take that one out, and this is the Steel Camel package. Now, if you remember, if you saw the original part of that video, this was flat, and it's definitely absorbed. It swells many times its size as it absorbs moisture. And so it still has a lot of capacity yet to go, but it certainly has done its job on pulling moisture out. Now, here is the Silica Desiccant. You can feel the moisture on both of these packages, but especially this desiccant. This is super saturated, okay? It's almost wet here, whereas the Steel Camel is still fairly dry. You can barely feel the moisture on it there. But again, this is by far worst case. Now, if you can see in here, there is more water taken out of the cup than there is here on the silica side. So this has pulled more moisture out of the air and into the Steel Camel Desiccant. So that is actually a good indicator of how strong this desiccant really is and how much it can absorb, because it's obviously still got room to go, but it has pulled, you know, 50% probably more moisture out of the container. And you'll see that result also in the data, because this desiccant is still working. This desiccant stopped working. And so if you had ammunition, if you had rifles, etc. in here, it would have started corroding, and you would have had visible condensation here on the sides of this. In fact, you can feel some. You can definitely, if you can see that, it has wiped the front of the container, and it's wet. So there's visible physical condensation all in the front of this container. I'll spin it around, maybe I get you a better view. But on this one, there's nothing. So the claims from Steel Camel apparently are pretty solid, because it is definitely pulling more moisture out, and it is avoiding condensation. Okay, this has a lot of condensation on the inside. Let me spin this around and we'll take a look. Okay, now I just spun it around, and looking down inside of here, see all the moisture and condensation? Really heavy. And so that would obviously corrode your weapons or your ammunition, just harm your primers or powder and things like that, whatever you're going to decide to store in here. And so that is the Silica Desiccant's job. It is totally saturated, no longer functioning for any kind of moisture control. And we're going to take this out and move it here carefully so we don't spill it. But you can see then the amount of moisture that's still left in that cup. Now if you compare it to the one here on the Steel Camel, there's actually closer to 50% of the water taken out of this cup, and yet no condensation on the sides of this case or on any of the brass. Okay, so it's not that the moisture wasn't high, but you've avoided it condensing, which is the real killer for our firearms. Humidity high is bad, right? It's bad, but condensation is really, really much worse. And so it has done an excellent job. So let me reposition this. We've got our scale over here set up, and let's measure how much water we've lost. Okay, let's take a look first at our silica gel. Let's weigh our gel and see what we get. So that is 7.335 grams. All right, at the end. And I'll put these stats up on the screen, but that means it absorbed 1.1 grams of moisture, roughly. It very, very close, within 3,000ths of a gram. So 1.1 grams approximately is how much our silica gel has absorbed. Now let's take a look and see how much water we've lost. Hopefully it's going to be a similar number, although we have condensation taking away from that value as well. So we have the ending here of our water mass at 30.883 grams of water there. We started, let's see, let me check these numbers. So we're ending here at 30.883. Oh, I think that's without the tear of the cup. It is. I'll have to do that in a minute. 1 second. Well, let's take a look at how much our Steel Camel Desiccant has gained weight. So our Steel Camel now is 11.549. So basically 11.55 grams. Okay. Now that is a significant gain. That is, let's see, over or just shy 6.8 grams of water it gained. But that's a huge gain. So it has significantly absorbed moisture from the water. All right. So now let's do our water cup out of the same container and see what it tells us here. Because this water amount was 30.56 grams from both of them, and we have 26.022 grams of water to start. And so by just the water, well, I got to take out the cup again. So again, I'll have to post these numbers in just a minute. I'll give you an updated number, but this has dropped. The other one did. In fact, it shows it slightly gained, but that's the cup. I got to take that measurement out to give you the final number. So just give me a second, and let's in just a minute I'll post all the stats. All right, so I've re-teared out our cups. I had to drain one of them. The Steel Camel I drained, dried out, and teared it out, and then checked our math again. So let's take a look at some of the results here. So first of all, the silica gel started off at 6.238, and it gained in mass 1.097 grams, or 1.1 grams. So not a lot of gaining of mass, so moisture directly into the gel. It did some, but it didn't do a lot. Now, the amount of water that was lost in the silica container, 2.688 grams. And so that's how much we lost out of the cup. And we saw this visual, this is the one out of the silica. The visual amount was lower, but yet we still have condensation and we still have significant issues in our container. And what it shows is we were easily able to supersaturate the volume of our container with this little bit of water. And so that's why we see it. And it's just really heavy condensation inside that can. And so that would obviously be a failure. It's starting relative humidity, 53.9%. Now that's common for both of them, okay? Ending relative humidity with the container and the silica gel, 99.9%, 100% humidity, saturation, therefore the condensation. And so that's again a significant failure. Trying to make it the worst possible case here in our containers, and it certainly failed. Okay, so that gives you some basic numbers there. In fact, the Govee alarm was set by default to go off at 97.8% relative humidity, and it was giving me several alarms that, hey, you've reached a humidity level you might want to check, and it's not so much a danger for the sensor, but it's just a pre-programmed alarm that you can set, if you wanted to say, I want to keep my humidity at 90%, well, you could reset that and it would alarm based on that. Okay, so the Steel Camel. In fact, let me get both of these out here so you can see them here. I'll give you the visual indication on the two. Now, that's a silica gel desiccant, sort of a standard thing. You buy them in bulk. Same kind of thing as in your safe dryers that you can take out, plug in, and recharge. In fact, just like this one here, which I'm recharging now. And so it's the same kind of material in there, and that one is it's hot because I just now literally unplugged it, drying. And so same kind of material that's in that one. Okay, and so what's the results for it? Well, the Steel Camel material, or desiccant, should say, it started at a 6.847, or excuse me, I'm saying that number. It started at 4.702 grams, and it ended at 11.49 grams. And so that's a gain in mass of water into this material, 6.847 grams. And so between these two, 1.1 gain in mass and 6.847. So it's basically more than six times the amount of moisture absorbed into here. Now, what's interesting also in this is that both dew points here ended at 70.5 degrees. And that's because that's an atmospheric condition, more or less, a measurement of that. But the relative humidity was 100% in the container, and condensation, et cetera, everywhere with the silica. But this one, the relative ending humidity was 91.7. And I'll post these graphs up here of the trend. You can see this arc that'll come up, and it flatlines. They both came up, and the silica gel, once it was done absorbing, humidity went to 100%. And it's as high as it'll go. Well, this one was continuing it just reached an equilibrium, and it still has capacity to continue to absorb, and it's holding the contents here at 91.7% flat line. I mean, it really did go. So it was basically over time just absorbing everything that was coming out of the cup as it could come out. And when you get to higher humidity levels, the amount of moisture will pull out of the container is smaller, and that's without temperature, where you would expand the air and expand the gaps between the molecules where you could literally hold more moisture. Well, then it reaches sort of an equilibrium. And you'll see also on those temperature charts over the last few months, it's all over the place, which is deliberate where I put it. So we would exercise the air and make it absorb and desorb maybe a little bit into our desiccant, into the container around it. And so significant difference. So just as a quick summary again, our Steel Camel desiccant has absorbed 6 times what the silica has absorbed. And it's still going, okay? It still has capacity, and it can still go. How much longer? I don't know. But after 2 months, you had to find some place to end the experiment, and so that's what we've done. So take a look at this data, judge it for yourself. I'll put the link to their site. They're not sponsored or anything by them. It's just simply they reached out to me and said, hey, we have something you might want to try that might be good in your industry, in the firearms industry. And so I said, sure, I'll take a look at it and test it. I'll give them an unbiased review. And so quite impressed. They really focus on controlling condensation, and it does. But when you control the humidity well first, which is exactly what it was doing by pulling everything it could out of the air, well, then condensation is a result, right? You never reach, at given temperatures, the amount of moisture to supersaturate and to release from the air and condense onto cooler cans. And that's the kind of good thing about doing these steel cans, right, is that when the temperature changes and it's been warm and it goes cold, the moisture will condense onto the cold surface, and it really pulls things out and puts it onto that surface, and you can really see that. So if you want, take a look again here, and we'll just take one more shot here of this heavy condensation through here. Make the decision for yourself. I think they're going to come out with some packages of these things for gun owners, maybe a little smaller quantities, etc. But take a look and judge for yourself. To me, long-term storage of this, of ammunition, primers especially. You can imagine you could stack, I have them like 7,000 primers in this container, and they get moist. And condensation, I'd be really upset. This will avoid it. Okay, whereas this clearly has reached its limit. Now you could throw 10 more bags in here. Well, in fact, 6 more bags to equal it in the same period of time. But then these are going to supersaturate. You're going to have to take them out and dry them, whereas this one is still doing the job, and there's been no worries to this point. So it's worth it to me for the protection to throw into expensive items. You're going to throw this into stuff you're just going to store for a couple weeks or something. Well, maybe not. But expensive thing like primers, maybe big powder cabinets, where you have a lot more money involved in things. Loaded ammunition, you fill this can with loaded ammunition, it's not worth quite a bit of money anymore. Well, then maybe this makes sense to you. You'll have to make your own judgment on the economics versus the risks you want to take. One other thing that is being done with these already is on very expensive firearms. When you ship them or when you store them, some people will store them in the cases they're in. And some, obviously in other safes. Throwing this in could really keep you safe in the long run from any kind of condensation damage, moisture damage. So you can, again, make that judgment for yourself. I'm not selling them. I'll put that link on there. You guys go check it out for yourself. But throwing one of these inside of a container, especially, or a small safe with extremely valuable items, I think will be worth it. So I hope you like this. It's been kind of a fun experiment. Maybe we'll do more in the future, I don't know, but I think this convinces me right away. These are going to go in each one of my primer containers right away and in one of my safes. So hopefully you like this. If you do, give me a like and subscribe.